Hello beautiful people, this is the science lecture video number 2 for semester 3 and I will start it with a quick revision about light rays. Light is a kind of energy made of electromagnetic waves. There are some types of light that are invisible such as the infrared light and the ultraviolet light. The white light is the visible light and it is made of 7 different colors. Help me to say them in order. Red, orange, yellow, green, blue, indigo, and violet. This is what the human eye can see. Light has different sources. Electric light bulbs are artificial light sources, while the sun is a natural light source. When the white light of the sun is blocked by an opaque object, a shadow is formed. So this is how shadows happen. They happen when the light of a light source is blocked by an opaque object. Are all objects opaque? No, they are not. Some objects let light pass through them easily. These are the transparent objects. Some others let some of the light pass through them and they are considered as translucent objects. Some opaque objects have smooth surfaces such as the mirror. So here is a mirror surface. It is so smooth, it reflects light. When an incident ray hits the surface of the mirror, it reflects. How do we draw the reflected ray? We should start by drawing a normal. Then we measure the angle of incidence. The angle of incidence must be equal to the angle of reflection, and this is how we will get the reflected ray. When light rays pass from a medium to another one, like from the air to the glass, the light ray doesn't continue in a straight way. It does not do this. It refracts. Also, when the light ray passes from air to water, it does not continue in this way in a straight line. No, it doesn't. It refracts. So light rays bend when they pass from a medium to another, and this process is called refraction. Now guys, look at the slide and tell me, what is the source of light in this slide? It is the light bulb for sure. The electric light bulb is the artificial source of light shown in this figure, but in order for this light bulb to light up, you will need electricity. You will need an electric current. What is electricity? It is the energy that we get when electrons flow from place to place. Let me give you a quick idea about electrons. Everything around you, everything in the world is made of small objects called atoms, and in these atoms there are tinier particles called electrons that can move from place to place. So when these electrons move from place to place, they give energy called electricity, which is current electricity. So you know now that today's lesson is about electricity. Again, what is electricity? It is the energy that we get when electrons flow from place to place. In order for electricity to flow, for the electric current to happen, you will need a closed path called a circuit. Scientists have learned how to generate electricity. You will need a source of electricity. In this case, we have the battery. You will need also a road for the electricity to walk in. So electricity will flow inside these wires. Look, electrons flow in the current. The circuits link electrical things together. In this case, you will see the switch and the light bulb, which is the device. All of these electrical objects, elements make a circuit. So the battery connected to a device and to a switch using wires make a circuit. What are the parts of a simple electric circuit? A circuit is usually made by linking electrical components together with pieces of wire cable. Let's start with the source of electricity. You will need something to generate electricity in your circuit. In this case, we have the battery. You will also, as I said, need roads for the electrons to flow. Here are the wires, the copper wires. And you will need a device since, as you know, electricity power different things as heaters, light bulbs, and computers. In this case, the device is the light bulb. Sometimes circuits have switches used to open or to close the circuits. Let's see, what's the difference between a closed circuit and an open circuit? I will start by identifying the elements or the components of our circuits. We have the batteries right here. We have also wires for the electrons to flow. We have the light bulbs as devices and switches. The switch needs to be closed. When you close the switch, electricity flows around the circuit. If there is a break anywhere in the circuit, electricity cannot flow. So in the second circuit, the switch is closed, it is on. So this is where electricity can flow. Electricity flows in complete circuits with closed loops. Here is an example of circuits. Is it open or closed? This circuit is open since, as you can see here, the wire is broken. The lamp will not light and the electricity cannot flow. It's an open circuit. Again, right here, look at the wire. The wire is broken, the electricity cannot flow, so this is also an open circuit. Look at this electric circuit. It is made of a battery, wires, a light bulb, and the switch. Let's look at the electrons. The electrons aren't moving since the switch is off. When I close the switch is on, electricity is flowing, and electrons are moving from place to place. This is a closed circuit. This is an open circuit. Let's use this to build an electric circuit. You will need a generator of electricity. You will need a device. In this case, I will put 2 light bulbs and I will add a switch to my circuit. The switch is on. You have to connect these electrical components using wires. Look, the switch is on, but the light bulbs are off. So what should we do? The circuit is open. We will connect them this way. Look at the light bulbs, they are on now. I will turn the switch off. The light bulbs are off and the circuit is opened. Turn it on. The light bulbs are on again. Electricity flows in a closed path, in a closed circuit and not an open one. This way the electricity cannot flow. Here is a simple simulation of electric circuits. We have a switch, the switch is on, a light bulb, the light bulb is on also, and an electricity generator, which is the battery right here. Let me turn the switch off. When we turn the switch off, the circuit is open, the light bulb is off, and no electricity is flowing in our circuit. Okay? I'll turn it on and I will add a battery. Look at the light bulb. The light of the bulb is stronger now. one battery. Look at the light of the bulb. I will add again a new battery. The light of the bulb is stronger. I'll turn it off and I will use a small fan, another device in my circuit. The switch is off. I'll use one battery right now and turn the switch on. Here is a closed circuit. The fan is on. Switch off. This is an open circuit and the electricity is not flowing. Switch on and I will add a battery. Look, the fan is turning faster now. A third one. Look, it's turning faster and faster. Let me change the circuit to symbols. Okay. What are these symbols for? Let's see. Scientists and engineers draw diagrams of circuits. So instead of drawing a battery, a wire, devices, they use symbols. As you can see right here, here is the symbol. Here is how to draw a battery. We draw a lamp this way. This is a closed switch, and right here an open switch. Let's go for an example. We have a closed circuit right here made of a battery, a lamp, a switch, and wires. What will we do? Here is the diagram of our circuit. We draw first the symbol of the battery, the symbol of the lamp, the symbol of the switch. I will close it since our circuit is closed, so I will close it this way. Okay, and for sure you have to connect the electrical component using lines or wires. Another example, we have a circuit with a battery. Here is the battery and 3 lamps. Let me circle them for you. 3 light bulbs. 1, 2, 3 light bulbs. The battery and the 3 light bulbs are connected using lines or wires. So as you can see, the symbol of the battery with 1, 2, 3 lamps connected by wires. Let me tell you an information about wires. You cannot use any type of wires. Wires must be made of conductor material. Conductors are materials that allow the electricity to flow freely, such as metals, while insulators like rubber or plastics, they do not allow electricity to pass through them freely. Look at this. Let me start. I'll wait for the wood to appear. When you put a piece of wood in your circuit, look at this, the lamp is off. This means that wood is an insulator. Copper, it's on, so it's a conductor. Glass off, insulator, and steel is a conductor. We'll go again. Wood off, insulator. Copper on, conductor. Glass off, insulator. Steel on, it's a conductor. When the light bulb lights up, this means that the electricity is flowing through the circuit and the circuit is closed. When it's off, this means that there is a gap. The circuit is opened. I'll use another example. Look at this. Look at the ceramics. Even when you close the switch, the lamp's still off. Okay, it doesn't light up. This means that this material is an insulator. It doesn't let electricity flow in the circuit. Look at the metal right here. When you close the switch, the light bulb is on. This means that metals are conductors. We build this circuit with water, some salts in it, The light bulb is on, so water is a conductor of electricity. We'll be using different materials in this circuit to check if they are conductors or insulators. Let me start with the metal. When you place a metal in your circuit, the light bulb is on, so the metal is a conductor. Plastic, the light bulb is off, no electricity flowing, so it is an insulator. Wood, light bulb is off, so the wood is an insulator. And that's it. This is what our lesson is about. We talked about electricity, which is the energy that we get when electrons pass or flow from one place to another. Again, current electricity is the energy that we get when electrons flow from one place to another. A simple electric circuit is made by linking a battery, a switch, a device using wires. We know now how to draw a circuit diagram. We have a symbol for the battery, a symbol for the lamp, a symbol for the switch and for the wires. And circuits, electric current happens when the circuit is closed. Electricity flows inside the circuit and turn on devices. You know that some materials are conductors, some others are insulators, metals, water are conductors, and wood, glass are insulators. If you still have any questions about the lesson, I will be glad to answer them all. Bye bye.